let's say a 10-sided die is rolled. These are the outcomes. A is an even number. What would A be then? 2, 4, 6, 8, 9, 10. Okay. B is a number less than 6. So what could that be?
1, 2, 3, 4, 5, 6.
C is a number greater than 8.
9, 10.
Okay. So the probability of B. How many outcomes are there? 10 for a 10-sided die. And how many of them are in B?
5.
So 5 out of 10.
50.
B, the probability of C. 2 out of 10. So 0.2. C, the probability of A and B. So there are 10 possible outcomes. I'm looking for which ones are in both set A and set B. So they both have 2. They both have 4. Do they have anything else in common? So there are only 2 numbers that are in both. So that is 0.2. A or C. I want to know how many numbers are in A or C. You did A or B.
5 out of 10.
6 out of 10.
Okay, so a couple ways you could do it. You could just count them. You could say, okay, A has 5, C has 2, but how many have I double counted? 1. So you could do it that way, or you could say I'm going to take all the numbers in A, and in set C, the only one I haven't used is 9. Either way, you get 6 out of 10, or 0.6. Probability of C given A. When you have a given, where does that number go? So A is my denominator. So there are 5 options. I know already then that it is either 2, 4, 6, 8, or 10. How many of those are in set C?
1.
Okay. Probability.
So it's
Choose
what's
the
in C and A is what it's asking in the
Yes.
first one.
The top has to be like A and C. The bottom is just A. So like here the probability of B and C, how many of them are in
2.
C? And then B if you know you're in C. So I know my number is either 9 or 10. How many of those are in B?
0.
Yep.
No solutions on
Oh, I know, you can't divide by 0.
Right. We can have 0 on top. Are A and B mutually exclusive? What does mutually exclusive mean? There's nothing in common. Okay. Do they have anything in common? So, no. My reason, if I ask for it, both have a 2 and a 4. Are A and C independent? The definition of independent says the probability of one has to be the same as the probability given the other one. I've done the probability of C given A. If they're independent, that has to be the same as the regular probability of C. What was C given A? What's the probability of C? So, are they independent? Yes, because those probabilities match.
Did you say mutual exclusive means that they?
No overlap. No numbers in common. What if I asked for the probability of, let's do, what if I wrote that? What does that mean? So you can do 1 minus your 2 out of 10, or you could say there's only 2 options here, so there's 8 that are not in it. So all right. Are those okay? Let's look at this one. In order to be accepted into a graduate program, applicants must get a qualifying score on the GRE and have an acceptable GPA. From past experience, an admissions counselor knows the probability of having acceptable GPA is 0.83. So the probability GPA 0.83. And that of those with the acceptable GPA, the probability of getting a qualifying score is 0.64. So the probability their score is high enough is 0.64. Except, what do I already know out of this? It's not just everybody.
Score and GPA.
Yeah, we already know they have the GPA. So that's the probability they get the score given they already have the GPA. It's 0.64. We want the probability they are accepted, which is they have the GPA and the score.
So it'd be 64 divided by 83.
Look at your formula sheet. So this is the general multiplication rule. It says probability in F is probability V times the probability of F given that E already happened. So the probability of GPA
0.83.
So when in doubt, write your formula. Your two options are either multiplying or dividing in this case, depending on what I give you and what I ask for. So if you look at your formula, you can figure out which one you need. Alright, any questions there? Let's look at this one. In a game, you draw cards from a deck containing 3 black cards and 5 red cards. To win another turn, you must get 3 black cards in a row. To win the game, you must get 5 red cards in a row. Find the probability of winning another turn. How do you get another turn? So I have to get black, black, black. Okay, what's the probability my first one is black? 3 out of 8, because I have a total of 3 black and 5 red in my deck. Okay, if I just took out a black card, what's the probability the next one's black? Then what's the probability the next one's black?
1/6.
Okay, so if I multiply those, I get 0.0179. Probability of winning the game. How do you win the game?
5.
Okay, what's the probability the first one's red? Next one? Next one? Next one? And the last one? Okay. And then we get 0.0179. Okay. So what would be the probability of not winning anything? Do I just subtract it once? Twice, because I have to subtract my probability of winning a turn and winning the game.
It's weird that it's just as likely to get the 5 in a row as the 3.
It is. It's only, yeah,
Because you think 3 in a row would be easier to get than 5 in a row.
right. There's less black cards in there, so it's, and more red cards. So it's just kind of a fluke in this one. It wouldn't always be the case. It would depend on your number of cards. And
Okay.
but any questions on that one? Okay. A survey was taken asking if middle school students like the current class offerings. So the probability of yes, given they were 5th. So if I say they're given 5th, that's all I'm looking at. How many people were in 5th grade? How many of them said yes? 20. Is it okay if I don't divide these? The probability of no. How many people said no? What would we have to do? Alright, let's add everybody up. So 121 said no, out of how many?
220.
And then you would get it from there. The probability they were eighth and yes. So what do I have to do? And means multiply, but is there an easier way since I gave you the table? Can you find the people that were in 8th grade and said yes? So all we have to do is 41 out of 228. So if I give you the table, sometimes we don't even have to use the formulas. We can just find the actual numbers. The probability of 8th given, they were yes. So my given is the denominator. 107. I'm only looking at these yeses. Out of those, which one were in 8th grade? And you can get that. Yes.
Why on C did you divide by 228?
Because I didn't give a condition, so that means it's out of everybody.
Oh, because the yes had to be on the bottom.
Well, it was just an and meant I was only looking for people that meet both of these requirements in 8th grade and saying yes. Since there's no, when it's that given, that's when our denominator is not out of everybody. Other questions? I do have some more. We'll try a couple more. I think I have 2 more on. I'm decorating pumpkins for a party. 65% of the pumpkins are carved. So the probability it's carved, 0.65. 73% are carved or painted. So probability carved or painted, 0.73. 21% are painted. What percentage of pumpkins are both carved and painted? What would we do?
Oh.
Yeah.
0.65 plus 0.21 minus 0.7. Right?
Yeah, well, in a roundabout way.
0.73
Yeah.
equals 0.65 plus 0.21
Oh.
minus.
But yes, I mean,
Yeah.
you're going to do that to get there. So, it's this formula. Probability of B, bless you, or F. Probability B plus probability of F minus probability of both. So then you could solve this.
Is that on the formula sheet?
Yes, the
It's on the
front page, very bottom.
Okay, very there. Yeah, it's called the generalization.
Oh, okay.
So there's a 13% chance my pumpkin is both carved and painted. And last one. It's basically the same, isn't it? So probably this or this is probability of the first plus probability of the second minus probability of both. And you could solve from there. Are you guys okay with solving that? You know the formulas we're looking at? Okay.